Now listen what I am saying carefully. Just try to understand what I am saying carefully. Put your brain here once again. This sign convention here, I wrote two sign conventions. These are the two sign conventions actually given in your textbook along with two more. Okay? I will write them also here. But what happened is in your textbook has given these two sign conventions we draw. We will correct them. But whatever is given in your textbook straight away, first I wrote that. Okay? Compound sign convention. So let us go for point number 3. So in point number, I am just taking 2 points called C and D. Okay. Now C, D. In C, D, you need not by traveling from C to D or D to A, you D to C, you need not worry about the direction of current there. Don't worry about the direction of current. Okay, you need not take the direction of current into consideration. Then what should we take, sir? Whether you are traveling from positive terminal to the negative or negative terminal to the positive, put it in your mind. So going from C to D, when you are going from C towards D, you are moving from the positive terminal towards the negative terminal. As we know, positive terminal is always supposed to be at higher potential. Negative terminal is always supposed to be at a lower potential. So that is why in going from C to D, this epsilon value, because there is a potential drop, decrease in the potential drop, that is why we take epsilon value as a negative value. This is the third sign. So when going from positive to negative terminal of a battery, epsilon is negative. Epsilon is negative. When where are going from? Going positive to negative terminal of the battery, epsilon is negative. Okay. Now, if I close this point number 3 here, I will be left with point number 4. Now, let us see what point number 4 says. Let me now say that I am moving from D towards C. Okay. So when you are moving D towards C, you are crossing the negative terminal first and then going to the positive terminal. As I said, negative terminal lower potential, positive terminal higher potential. So what happens? You are going from a lower value to a higher value, which implies epsilon should be taken as a positive value. So from D to C. Okay, here also I am writing the same. When going from negative to positive terminal of a battery or a cell, whatever you write, there is no problem. Battery, epsilon is positive. Okay, so I put 2 points here. Now, one point says that when I go from the positive terminal of the battery toward the negative, I am repeating it once again. Don't worry for the current direction there. No worry for the, I did not draw any current here. So no worry for the current direction. Only see whether you are going from positive to negative terminal. Yes, you are going from positive to negative. Then epsilon should be taken as a negative value. Second one, D to C. When you are moving from D to C, for example, you are traveling from negative to positive. Then again, the epsilon value should be taken as a positive value. Okay, so these 2 points right now. And now what I will do is I will make correction in these 2 points, 1 and 2. Okay, there is not a big wrong there. A small wrong is given in your textbook. Let us correct that, or else you will not get any correct answer. I will give the reason for that now. See here. Let us apply the points here for this circuit. From A to B, when you are traveling from A to B, what is happening is you are traveling saying here? When you're traveling along with the current, he said that take the value of this as positive. Is it not? Plus IR. Now, what it said that the algebraic sum of the EMFs and potential differences in a closed equation is equal to 0. Algebraic sum is whatever is the sign given to this one, that sign. So I should put it as plus IR. Okay, now this part is completed. B to D, there is no resistance, there is no EMF, nothing. D to C, when you are coming from D towards C, you are crossing the negative terminal and entering the positive terminal. What is the rule saying? When going from negative to positive terminal of a battery, epsilon should be taken as a positive value. So epsilon positive. But what is the statement? First statement saying? It says that the algebraic sum of potential difference and EMF must be equal to 0. If I put this is equal to 0, then I have epsilon is equal to minus IR. This is absurd. This is not actually correct. Or else somebody might say, sir, IR is equal to minus epsilon is also correct. Okay, but epsilon values will never be taken as negative values. Means the battery will never say that battery is minus 5 volts. This is not minus 5 value. So that is why this value saying that minus epsilon is equal to something absurd here. This is absurd because these two have been given wrong. Okay, so that is why we will be correcting this saying that when you are, sir, why should we take this as like that? I'll also explain that also. When you are traveling from A to B, the current always flows from a higher potential to a lower potential. I repeat it once again. When current is traveling from A to B, it is flowing from a higher current can only flow from a higher potential to a lower potential. So A should be at a higher potential, B should be at a lower potential. So as the current is flowing from A to B, so the cross distance should be taken actually as a negative value, but in your textbook it is given as a positive value. So that is the wrong given in your textbook. That will be taken. So I will make you to write it as a note point. For now, just note down these two words. Have I completed that? So the important part is, did you understand what I said? What is the wrong given in your textbook? So did you understand what is the wrong given in your textbook? So when you're traveling from A to B, current travels from a higher potential towards a lower potential. Current always travels from a higher potential towards a lower potential. So when current is traveling from a higher potential to a lower, the potential difference between A and B should be taken as a negative value. but in your textbook it is given as a positive value. So VAB should be taken as a negative value, not a positive value. That is wrongly given in your textbook. Similarly, traveling from B to A, we are traveling against the current. Okay, current always travels from a higher potential to a lower potential, no doubt. But now what we are doing, we are traveling against the current. Okay, when you're taking traveling from against to the current, then you're traveling from which potential to which potential? From lower potential to higher potential. From B to A means you're traveling from lower potential to a potential value. So that is why it should be taken as a positive value. So point 1 and 2, the positive and negative sign should be changed, or else you will never get your answers. So that is the wrong given in your textbook for all of you. Now say me whether you have understood or not. So now put a note point in your notes. Put aside note point. Note point. Note point number 1. When traveling from A to B, when traveling from A to B, as we travel from higher potential to lower potential, as we travel from higher potential to lower potential along the direction of current, along the direction of current, along the direction of current, the potential difference IR is negative. Okay, point number 2. When traveling from B to A, when traveling from B to A, opposite in direction to the current, when traveling from B to A, opposite in direction to the current, as the potential increases, as the potential increases, VAB is positive. VAB is positive. That is, IR is positive. That is, IR is positive. That is, IR is positive. Have you completed it now? Now in the exam also, actually, whatever are the note points now you have written, note point, they have to be written as point number 1, point number 2 as sign convention. Okay, now let us see if the book is, for example, the next year the new version has come or not, I don't know. At least if you can there is no problem. Or else in the exam, you are writing whatever you have written there, you have to write in the exam that only. As the note points you have written there, that note points have to be written as the first and second points in science, and it or not. Yes, thank you now. So now let us apply what we did now to the circuit on the board now. See there now circuit on the board once. A to B, we are following the current direction we are. So if you are following the current direction, according to your node point number one, should be a negative value. Am I correct or not? Say yes or no. IR should be a negative value. So minus IR. Next, from B to D, there is no resistor, nothing there. Next, come to from D to C. When you're coming from D towards C, there is negative terminal to positive terminal. For saying, the rule for saying is saying that when you're traveling from negative to positive terminal, the epsilon value should be a positive. So that is why we can write it as positive. So total value should always be equal to 0. So minus IR plus epsilon is equal to 0. There will not be that negative sign. So finally you will have epsilon is equal to IR, which is correct. Could you understand it now clearly, all of you? Yes, so in the exam also, whatever you have written note points there, write those note points as point number one, point number two. So probably you might have a doubt, sir, why did you tell that point number one, point number two like that only as in our textbook? The reason is, afterwards when you write, you see your textbook, you will all have a doubt. Sir told wrong, sir told wrong. No, say wrong. Your textbook is actually given wrong there. Okay, so we have corrected that. So in order not to have any confusion, I actually told those points 1 and 2 as is in your textbook. But when you're writing in the exam, write them as note points till now. So when you're writing in the exam, whatever is given in note point 1 and 2, you have to write it in the exam. Okay, and number 1, point number 2 in the sign convention. So I think I am clear in that. So are we clear now? Have all of you understood it? Yes, thank you. Now, let us now go to the essay question number 6. Essay question number 6 in your, thank you all of you. Essay question 6. SAQ 6. Derive the Wheaton, Wheaton, T silent there. We pronounce that as Wheaton Bridge, not Wheatstone Bridge, Wheaton Bridge. Wheaton Bridge. So this is a very important question for either 3 marks or 5 marks. Why we are saying as either 3 marks or 5 marks means if a problem is attached to this one, this becomes a 5 marks question. If there is no problem attached to this one, this becomes a 3 marks question. Okay, so as far as the time permits, I will just draw the diagram first for this one. Just put it in your notes. If there is time for us, we will continue for the derivation part also. So there is one of the most easiest of questions if you can understand, and one of the most difficult questions if you try to mug up. So don't try to mug up it. It's a very simple question. You can understand it very easily. Now have you completed the diagram, all of you? So now concentrate on the diagram part, what I am telling. Don't write anything extra. This also you'll have a soft copy for you. I'll be sending it for your cell phones. Okay. Now listen there. Now I got a circuit where I've got four resistors PQR. You can see in the diagram PQRS are four resistors, and there is a battery connected there which is giving out a current called I. Current I reaches point A, it finds two paths. One path is along P, the second path is along R. The current traveling into P is equal to I1, and the current traveling into R is equal to I2. Again, at the point B, you can see that current I1 which is going towards B will find two paths, one traveling along the galvanometer. Galvanometer is a device which can show whether current is flowing or not. Galvanometer is a device which can show whether current is flowing or not. Okay, so into that galvanometer there is a current Ig flowing, and there is a current called I3 flowing from the resistor called Q there. How is Ig and I3? Ig and I goes to B and splits up. It splits into Ig and I3. Okay. At the same I2 will, so all rest of them I3 and I4 will meet at C, and again the current I will flow through the circuit as shown in the diagram. I repeat that once again, let us see. I is the current flowing through the circuit. I reaches A, flows through P. At B, it splits into two parts, I3 and Ig, and I3 flows through Q, Ig flows through the galvanometer, and Ig meets with I2 at point D, they flow as I4. And next, I4 goes to C, at the same time I3 comes to C, both of them will meet at C, and again they will flow as I through the circuit. Now, he is asking you to derive a condition called the balancing condition. What do we mean by a balancing condition? A condition under which potential difference between points B and D is equal to 0. I repeat it once. A condition under which the potential difference points B and D is equal to 0. If there is no potential difference, there is no current. Means the condition under which value of Ig becomes 0 can be called as the balancing condition. Have you understood what I told? So under the condition, what happens? Ig becomes 0. Okay. So if Ig has to become 0, then how should we take PQRS? That is what is being asked. How should we take the values of PQ, R and S? So that is what we mean by the balancing condition. So in the balancing condition, current flowing through the galvanometer. That is what you should understand. Okay. Now I'll put one by one equations. Exactly, I have got 8 minutes of time from now. Probably all the equation might not be completed. I'll be explaining this once again tomorrow also. For now, whatever is the time possible for us, let us use it. and just derive some part. Okay. Now listen carefully. Don't take your pens. Listen carefully. Junction B at junction. Which junction I'm saying? B. Here, the current I1 actually comes towards the junction and it speeds of G and I2. Is it not? So, in the Kirchhoff first rule, we have written that the current towards the junction should be taken as a positive value and the currents leaving the junction should be. But when you add the total values to be equal to 0, so at junction B, I1 should be taken as positive and I3 and I3 should be taken as negative because they are leaving the junction. So minus of I3 plus I3 will be equal to, I can get I1 resistance of the galvanometer, again I have a value of minus Ig into G. Sir, what are you writing? You are putting I into P, I into G. How can you write all this? We have got a Ohm's law saying that potential difference V is equal to IR. IR. Always resistance need not be shown with only a value for that part of resistance here. P. What is the resistance here? G. Now come here now. From here, we have completed BD, next DE. And from D towards A, you are traveling against the current frequency. So when you are traveling against the current, according to your rule number, note number 2 in your notes, what should be written? This should be taken as a R I2 is equal to I1P plus. So today, Bob, the time will be sufficient for us for writing these three equations. Just put in your notes. And today, I have completed all of you. Have I completed all of you? Yes. So I think still we have got 2 minutes of time or 3 minutes of time. Just let us write the next point also. Write down. Using mesh rule for using mesh rule for using mesh rule for the mesh using mesh rule for the mesh A B C D A. We are using for A B C D A total mesh. Then from A to B it is minus I1. Next minus, because I am traveling with the current, minus Q into I3. The current is traveling against me. So plus I4 into S plus, because here also the current is coming against me. I2R is equal to 0. So from where I can write this as I4S or Pi1 plus Qi